That is the kind of headline that makes people stop scrolling. It sounds impossible. It sounds too good to be true. And to be completely honest with you, as stated like that, it is too simple. But inside that dramatic headline is a real scientific story. And it is one of the most fascinating stories in modern cancer research. Because what if one of the biggest missing pieces in cancer was not just the tumor itself? What if part of the answer was living inside your gut? What if the thing that changes the outcome is not only the drug, not only the surgeon, not only the scan, not only the genetics of the tumor, but also the invisible ecosystem inside your body that is talking to your immune system every single day? I'm Dr. Sophie Hale, and today I want to walk you through something that sounds almost unbelievable at first. Not that a miracle bacterium swoops in and wipes out every cancer. Not that yogurt cures tumors. Not that one supplement changes everything overnight. But something, in a way, even more interesting than that. The possibility that certain gut bacteria may help your own immune system recognize cancer, respond to treatment better, and in some cases do what we once thought was nearly impossible: push back, hard. Let's start with the part almost nobody talks about. Your body is making mistakes all the time. That sounds scary, but it is normal. You are built from trillions of cells, and those cells divide, they copy, they repair, they replace themselves. That is life. But every time cells copy, there is a chance for typos, tiny errors, little mutations. Most of those mutations go nowhere, most never matter, most are fixed, and many of the ones that are not fixed are caught and cleared by your body before they ever become a visible diagnosable cancer. That is one of the great hidden truths of human biology. People tend to think cancer begins the day the doctor finds it. That is not really how biology works. Long before a scan, long before a symptom, long before a diagnosis, there may have been years of cellular mistakes, corrections, immune surveillance, failed cells, dead ends, and near misses happening quietly in the background. In other words, your body is not passive. It is not sitting there doing nothing while disease builds. It is actively patrolling, actively editing, actively destroying cells that should not be there. Think of it like this. If your DNA is a massive instruction manual, every time a cell divides, your body has to retype pages from that manual. Now imagine retyping the same giant book over and over and over again for decades. Typos will happen, of course they will, but your body has proofreaders, repair systems, quality control teams, and one of the biggest quality control forces you have is your immune system. Your immune system is not only there to fight colds, it is not only there to handle infections, it is also there to identify abnormal cells, cells that are behaving strangely, cells that no longer fit the rules, cells that may be drifting toward cancer. And when that system works well, many dangerous cells never get the chance to become a crisis. That alone should change how we think about health, because it means the story is not just, how do we kill cancer? The story is also, how does the body normally keep cancer in check? Now here is where things get really interesting. For a long time, cancer treatment was dominated by a straightforward logic: find the tumor, cut it out, burn it, poison it, starve it, shrink it, target it. And to be clear, surgery, radiation, chemotherapy, and targeted therapy have saved countless lives. This is not an either-or conversation. This is not a rejection of standard medicine, but in the last couple of decades, something extraordinary started to happen. Doctors began seeing that in some patients, if you could properly activate the immune system, the body could do something astonishing. It could mount a serious attack against the cancer itself, not metaphorically, biologically. This is the world of immunotherapy, and when immunotherapy works, it can look almost unreal. You can have two patients with advanced cancer, same general diagnosis, same class of drug, same stage on paper. One gets little benefit, the other has a deep response that lasts years, and that raises a huge question: why? Why does one immune system wake up and attack while another barely moves? Why does one patient respond and another not respond? Why can the same treatment look almost miraculous in one person and disappointing in another? Part of that answer may be hiding in the gut. Now, when most people hear the phrase gut bacteria, they think digestion, they think bloating, they think yogurt commercials, they do not think cancer medicine. But your gut microbiome is not just a digestive accessory, it is an immune organ in conversation with the rest of your body. It helps train immune cells, It helps shape inflammation. It helps produce metabolites. It helps influence the environment your immune system is operating in every single day. And if that internal ecosystem is off, your immune response may also be off. That is why scientists became fascinated by a very strange possibility. What if the bacteria living in the gut affect whether cancer immunotherapy works? And then the data started arriving. Not perfect data, not final data, but very serious data. Researchers began seeing that patients with different microbiome patterns had different responses to checkpoint inhibitors, a major class of cancer immunotherapy. And one bacterium kept showing up in this conversation: Akkermansia muciniphila. That name may sound obscure, but it has become one of the most talked about microbes in this area of research. Here is the big idea. Akkermansia does not appear to be a tiny assassin swimming through your bloodstream looking for tumors. That is not the story. The story is more elegant than that. This bacterium may help create conditions that improve immune performance. It may support a gut environment that helps the immune system respond more effectively. It may strengthen the signaling, readiness, and coordination needed for treatment to work the way it is supposed to work. And that matters. Because in cancer, recognition is everything. A tumor survives partly by hiding, by confusing the immune system, by turning off alarms, by exploiting the body's own brakes. Checkpoint inhibitors work by releasing some of those brakes. But if the whole immune environment is weak, disorganized, or poorly primed, releasing the brake may not be enough. You can take the parking brake off a car, but if the engine does not start, you are still not going anywhere. That is where the microbiome may matter. It may be helping start the engine. One of the landmark moments in this story came when researchers found that patients with lung and kidney cancers who did not respond to PD-1 blockade tended to have low levels of Akkermansia muciniphila. And then came the part that made scientists pay even closer attention. In mouse experiments, after antibiotics had damaged the microbiome and reduced immunotherapy response, giving Akkermansia back helped restore the response. Now pause there, because that is the difference between a fun correlation and a serious biological lead. It is one thing to notice that responders and non-responders have different bacteria. It is another thing to change the bacteria and then see treatment response change in an experimental model. That does not mean the entire story is solved, but it means this is not just noise. This is not just coincidence. This is biology talking. And biology rarely whispers without a reason. Other research groups have found additional microbiome patterns linked to immunotherapy response as well.
Different cancers,
different patient groups, different microbial signatures. Some studies have pointed to bacteria associated with better immune infiltration in tumors. Some have linked baseline microbiome composition to longer or shorter survival. Some have shown that the gut may influence how effectively immune cells are activated in the first place. So the emerging picture is not that one magic bacterium cures cancer. The emerging picture is that cancer treatment outcomes may partly depend on the biological neighborhood your immune system is living in, and that should make all of us think differently. Because it means the future of cancer care may be less like dropping a bomb and more like restoring an ecosystem, less like brute force alone and more like coordination, less like one silver bullet and more like a systems approach. Tumor biology, immune biology, microbiome biology, metabolism, inflammation, timing, all interacting. Now I know what some people are thinking. If this bacterium is so exciting, should everyone run out and buy a probiotic? Not so fast. This is where people get into trouble. They hear one study, one molecule, one supplement, one name, and suddenly they think they have discovered a shortcut around oncology. That is not how this works. Commercial probiotics are not automatically the same thing as the bacteria used or studied in clinical research. Dose matters, form matters, context matters, cancer type matters, treatment type matters, and most importantly, evidence matters. There is a huge difference between a promising research direction and a proven standard of care intervention. You do not want to replace oncology with internet enthusiasm. You want to bring good questions into oncology. That is the mature way to use this information. Not panic, not hype, not magical thinking, precision. So what should people actually take from this?
First, the old idea that cancer is only about the tumor is too small. Cancer is also about the host, the terrain, the immune system, the internal environment in which the disease is either challenged or tolerated. Second, your body is doing more than you think. Even when you are not aware of it, there are defenses trying to identify and eliminate abnormal cells. That matters psychologically as much as it matters biologically, because too many people imagine the body as weak, passive, and doomed. That is not what the research suggests. The body can be misled, the body can be overwhelmed, the body can be damaged, but the body can also fight. Third, the microbiome may become part of personalized cancer medicine. Think about how radical that is.
A future in which doctors do not just ask, what mutation is in the tumor? They also ask, what is the immune state of the patient? What does the microbiome look like? What therapies might work better together? What needs to be repaired so the patient's own defenses can engage? That is not science fiction anymore. That is the direction the field is moving. And if you want to understand why this matters emotionally, imagine two worlds.
In the old world, the patient is told, here is your cancer, here is your drug, we hope. In the new world, the patient is told, we are going to understand your tumor, your immune system, your biological response patterns, and maybe even the microbial ecosystem helping shape that response. That is a very different level of sophistication, a very different level of hope. Still hard, still uncertain, still medicine, but more intelligent medicine. Now let's talk about something else people desperately want to know. Does this mean cancer can be prevented with bacteria?
The honest answer is not in a simple, clean way.
Not yet. The microbiome almost certainly matters, but cancer is not a one-cause disease.
It is not one switch. It is not one pathway. It is not one villain. It is genetics, environment, aging, immune function, inflammation, exposures, metabolism, chance, and time. The microbiome is one major player in that orchestra, but it is not the whole orchestra, and that is important. Because when science gets translated into headlines, complexity gets flattened, a nuanced finding becomes a miracle claim, a real therapeutic lead becomes a universal promise, and desperate people can get hurt when that happens. So let me say this clearly. There is no evidence that one bacterium alone universally makes 99% of cancer cells self-destruct in all people with all cancers. But there is real and exciting evidence that certain bacteria may help the immune system respond more effectively in ways that could meaningfully change outcomes for some patients. That is still a huge deal. That is still revolutionary. It is just revolutionary in a grown-up way, not a fantasy way. What I love most about this research is what it says about human biology. It says the body is not merely a victim waiting to be rescued. It says the immune system is not a background character. It says the gut is not just a food tube. It says cancer therapy may work better when we understand the entire human system, not just the visible tumor. And that changes the emotional texture of the conversation, because cancer has always carried this feeling of betrayal. My own body turned against me. My own cells are trying to kill me. And yes, cancer does come from our own cells, that part is true, but there is another truth running right alongside it. Your body is also trying to save you, your immune system is trying to recognize danger, your repair systems are trying to correct damage, your internal ecology is trying to maintain balance. This is not a body doing nothing, this is a body in conflict. And once you understand that, the whole story becomes more hopeful. Now if you are a patient, or you love someone with cancer, what can you do with this information right now?
You can ask better questions. That matters.
You can ask whether immunotherapy is relevant to the specific cancer being treated. You can ask whether there are clinical trials involving microbiome-related strategies.
You can ask how antibiotics, nutrition, and overall treatment context may affect the body during therapy.
You can ask whether anyone on the care team is thinking beyond the tumor alone. Because medicine moves forward partly through better questions, not just better drugs.
And outside the clinic, this research is another reminder that health is built as a pattern, not a trick, not a hack, a pattern, a diet that supports overall metabolic and gut health.
Sleep that helps immune regulation. Movement that reduces metabolic dysfunction. Less unnecessary inflammatory chaos. Less obsession with miracle foods. More respect for the entire system. That does not mean perfection. It means direction. It means understanding that the terrain matters. And maybe most importantly, it means not waiting until disease is advanced before becoming curious about the conditions that shape health. One day, I believe we will look back and realize that the microbiome was one of the major missing chapters in the cancer story. Not the only missing chapter, but one of the biggest. A chapter that helps explain why some treatments work beautifully in one person and fail in another. A chapter that helps bridge oncology, immunology, nutrition, metabolism, and preventive health. A chapter that forces us to stop thinking in straight lines. Because biology is not a straight line, it is a network. And cancer is not just a lump, it is a relationship. A relationship between abnormal cells and the environment that either permits them or challenges them. A relationship between mutation and immunity. A relationship between tumor strategy and host resistance. A relationship that, it turns out, may be influenced by microbes so small you will never see them.
That is astonishing.
And it should humble all of us, because some of the most powerful forces in medicine are not the loudest ones, not the biggest machines, not the most dramatic procedures. Sometimes the force that shifts the whole outcome is microscopic, quiet, invisible, living in the gut. If that sounds unbelievable, good. A lot of important science sounds unbelievable the first time you hear it. The key is to stay curious without becoming gullible, hopeful without becoming naive, open-minded without abandoning standards. That is how you use cutting-edge research wisely. So no, the real story is not that one bacterium is a magic bullet that destroys 99% of cancer cells in everybody. The real story is better than that. The real story is that your immune system may be far more trainable, supportable, and biologically responsive than we once imagined. The real story is that the gut microbiome may be one of the hidden levers that helps determine whether that response succeeds. The real story is that some of the future of cancer medicine may come from learning how to help the body do what it was trying to do all along: recognize danger, organize a defense, and finish the fight. Cancer is not only a story of cells growing out of control, it is also a story of defenses that can fail, defenses that can recover, and defenses that, under the right conditions, may become powerful enough to change everything.
And inside that story, yes, a bacterium may matter, not as magic.
As biology, and in medicine, when biology starts revealing a new lever, we pay attention.
Because that is often where the future begins.
Scientific grounding used for the script. I kept the script's central mechanism aligned with the current evidence that the gut microbiome can influence anti-tumor immunity and immunotherapy response, and that Akkermansia mucinifila has been associated with better response in some settings, with mouse data supporting causative potential. NCI Science. I also reflected the more cautious clinical reality that this is an active research area rather than a universal cure, and that microbiome response links have been studied across cancers including melanoma, non-small cell lung cancer, sarcoma, and glioblastoma, with findings still being refined. MD Anderson, NCI.